share screen. There we go. Okay, can you see my fourth? So this is fourth running
We
on an
can see your list, knowing it is no at the
Yeah,
top.
exactly. So this is fourth running on an FPGA using the MeetCrisp soft core processor. And we can do, let's see. Ta-da! There's even a reset button. And of course, I'm not a fourth developer. So the next thing I have to do is learn how to program in fourth. So that's going to be interesting. And then one or two directions. One is we want to do audio generation, and the other is to run multiple cores on these tiny FPGAs. They're like $35. If anybody has any questions, I'm happy to answer. Thank you.
Oh, I have a question.
Just speak, I'm listening, but loudly, please.
I have a question, Andy.
We hear you, Andy, but your volume is very low. So tell us your question, and if necessary, I'll repeat it.
Okay, I'll speak closer. I guess I can increase my volume. But anyway, I wonder if there's any Linux involved, or is this bare metal type of fourth?
Yeah, so this is actually, this is a Pico Ice board. It has two chips on it. One is the Raspberry Pi 2040, which is, I think, what you're using already, and the other is the FPGA. And so I was a bit distracted when you were speaking because I was trying to get this thing running, but applications like yours that are computationally intensive and require parallel processing are really good for FPGAs. You think of GPS or I have a rough idea of what you're doing, but not exactly. So does that answer your question?
Yeah. And what I was going to say is that when you're doing things just on that Raspberry Pi, I've been told by my Linux guru friends in the Bay Area that you run into unexpected things. Linux does things in the background that might screw you up. So, but I guess this application the guy's talking about does the heavy duty stuff in the FPGA. So I guess Linux cannot clobber him in any way, I hope.
Yeah, so in particular, you can't do like hard real-time things on Linux, but if you have a dedicated processor, then you can.
Well, good. I may try that someday.
Yeah, so the general strategic direction for this is on the RP2040, people are going to be running like MicroPython, which is really easy to develop, but it doesn't do the hard real-time stuff. And then you do the computationally intensive stuff on the FPGA. So the group of us who are discussing this on Discord, we're a little bit lost about where the market is, and we're poking around. It's just fascinating discussions out there, amazing links to interesting products. There's now, yeah, okay, enough said.
Oh, may I add a comment in that connection?
Sure.
You know, the so-called Kraken direction finder, Kraken, very popular now. It uses a Raspberry Pi 4, and it does very sophisticated algorithms collecting data from 5 antennas concurrently, and it does a lot of heavy-duty math, eigenvalue, matrix computations. Yeah, I should tell those guys maybe to talk to you. They might maybe want to improve that Kraken system by adding FPGA. As far as I know, it's not involved.
So the question is the computational load on the RP2040. If it has some extra headroom, then don't mess with an FPGA. But if they're getting to the point where it doesn't, then that makes sense. One of the applications that people are interested in, of course, is matrix multiplication. So if you look at Python on the sort of the desktop or some server, there are C-based libraries that do matrix multiplication on multiple cores very fast. And one of the application areas we might do on this is very fast matrix multiplication for the RP2040. The RP2040 only has a single multiplier, whereas even the low-end FPGAs have 8 multipliers. So you should be able to do things much faster.
Oh, may I make another comment?
Sure.
Yeah, okay. So another related area is radio hams using FPGAs to do like a complete transceiver, single sideband, CW, everything else, using most of the heavy duty jobs done by the FPGA. And I don't remember what platform they used as a background, but yeah, some of them might want to know about what you're doing.
Yeah, so if you put so that's really interesting to me. If you put a link in there, if you put a link in the chat, I'll definitely take a look. But the group that I'm working with is clueless about our radio frequency stuff, and clearly it's very important.
Okay, I'm trying to find a pen here. Well, anyway, you can send me an email, then I'll look around for the link for you. It's Kilo Romeo 6 Delta Delta. That's my
Hold on a sec.
call sign.
Can you say that again, please?
KR6DD at yahoo.com. Oh, and I have another Gmail. And my Gmail is fourth.fanatic at gmail.com.
Okay, I'll send you 2 emails. Thank you so much.
You know, one thing I'll comment on this is a really major, motivation for Cozy is to be able to write that mathematics as succinctly as any equations in any textbooks, but have it run, but be open to the hardware, which is evolving into FPGAs, so you can hand it out as broadly as you want. Actually, on Facebook, an old employee of mine at Rochester actually showed I guess it's called, I'd have to look it up on my daily blog, but essentially AI produced image of him in front of an AI produced globe, and talking about that, and we just had a couple of comments, but one of the things, and I think that is really, if you're going to be involved at all in AI or any of these things, you're talking about having, well, he said, really big arrays. I mean, it's all a game of really big arrays and really fundamental. I mean, a dot product, my definition of a dot product in Cozy is 2 words, okay? So if you want to actually work at that level, but have it based in forth, all the way down to the chip, then that's a major piece of the motivation of Cozy.
There's a lot of noise on the line, but so this matrix multiplication is clearly a very hot area, and particularly for AI. Actually, I'm taking a course on this semester. It's not clear to me. So, and my interest is not a single 4th core. It's like, hundreds of 4th cores, and it's not clear at all to me how to split up matrix multiplication across multiple cores. And so, if anybody has an insight on how to do that, I would be most interested.
I don't know. I mean, the definition of a dot product is and actually in APLs it's generalized to F dot G, but essentially it's applied G pairwise, and that's just intrinsically parallel, and then it's a sum across those. I mean, that's what it is in Cozy is it's times and then plus slash.
Yeah, on a single processor, I totally get how to do it. The question is, how do you split that up across multiple processors?
Additions.
Pardon?
Yeah. Or those multiplications. Those multiplications.
Do you duplicate the data? Do you duplicate the data? Does some data sit here? Does some data sit there? What's the communication between them? Answer is not at all clear to me.
Or, or or do you spread all the data across your, that's the whole thing, is mapping the data and having the data local to the process. I think in terms of a lot of architectures, that's where a bunch of it is going. They talk about having the operations and that's why, in a sense, a fourth size processor makes a lot of sense, where you have a little bit of a processor and a little bit of memory,
Exactly.
or an amount of memory. So the data is distributed with the processing.
So in the meantime, I'm staying away from the matrix multiplications and focusing on, sine waves and audio and stuff like that. Thank you for the link.
Do you guys still hear a noise? I think it was from my computer here.
We're still hearing the noise. Yeah.
Yeah, we're still hearing the noise. Could you mute, Andy?
Well, my hearing is not so good, but my wife tells me that there's a very high frequency squeal feedback with this laptop. I'll have to drop back my audio gain. Yeah, I can.
Yeah, I think that there's some issue. Your volume is very low, and I think you're emitting a squeak, or you were, but you need not.
Okay, I'm trying to find the gain control. I got to drop it down.
Okay, Andy, maybe fix it offline and come back next month, unless you have stuff that you really need to say. All right. Are there any other comments, questions, slanders, libels for Chris? All right. Chris, are you planning on giving like a 10-minute overview of your activities on fourth day? I think it would be very welcome.
I guess I am then. The school starts, I'm going to be very busy, but it's a great community here. So I guess my responsibility is to send you a 2-sentence paragraph at least a week before, a 2-sentence description at least a week before that.
Title and a 2-sentence description. As you all know, I'm at Forther, Forther, at Comcast.net. Maybe send me an email, any of you, just so that I have your email address and I can dun you at will. I'll try to restrain myself from spamming you unnecessarily. But fourth day, even if you just throw together in the next couple of weeks, if you throw together a video that's 10 minutes long, we'll show it. And you don't have to worry too much about being busy in November.
Okay.
All right. We'll take that as enough of Chris for now. Any other comments, rumors, innuendo, slander? I guess we've been over libel, reminiscences. Okay.
I can give you one piece of news. I just got laid off this week. So
I'm so sorry.
Got a job? Yep.
Just like to put out a general inquiry. Does anybody have a good stable sort function? I sort
Stable
of
sort, S-O-R-T?
sort, S-O-R-T. The
Yes.
the sort function that is really clever by this guy, um, oh, over in Austria, who did it for Riva, um, is really elegant and very short, but the problem is that it's not stable. If you have two equal values, they will get inverted. And if you're going to apply this across the columns of a matrix of an array, you can't have a later sort. And I learned, because I put the question out on this fourth group on uh, Facebook, but and I learned that the term for a stable sort, a stable, but the references, nobody had actually an algorithm that they could point to in fourth, for this really, fundamental action.
Brad has sent you a link to TimSort on
TimSort.
But you're looking for an implementation, is that right, Bob?
Yeah.
No?
Yeah.
Yeah, actually, I don't know that I've ever seen Tim sort of implemented in Forth, which now you're making me think that sounds like a fun activity.
It's like, yeah, no, I wanna waste somebody else's time on it.
Okay.
I think that will be Bill Ragsdale's presentation next month.
And many years ago, I did a contest of sorts, and the one that seems to always win, at least at that date and time, was a bin sort. Basically, if you've ever seen a card sorting machine, it has a bunch of bins, and you do it with bins, and that is very fast. That's the fastest sort I've seen.
Yeah, you need to animate the cartoon of the sorting machine.
Yep.
I remember Knuth
that's
had at least a chapter on sorting data on tape drives. That was instructive.
I think that's what's called a merge sort.
Yeah, it's effectively a merge sort. Yes.
Yeah, where you go and drop. I mean, this is the thing is I got links to, okay, here's where the algorithm is, but hey, somebody has to have done this. Somebody has to have this in Forth.
Look back in the history, and you'll find a whole bunch of Forth implementations of sorts.
Therein lies numbers of nightmares.
Yes.
Looking back is sometimes troubling.
Yeah, I can't even remember where it would have been published.
Or if.
That's, yeah.
I think it made it into Fourth Dimensions.
Well, as you all know, Fourth Dimensions is available in the on the FIG website, and may also be, at least in part, on archive.org through separate means. I gather it seems to me I ran across at least some Fourth Dimensions stuff on archive.org. But I would like somebody other than me to make a list of resources that have been paper resources that have been scanned and where they can be found on the web. I know where Fourth Dimensions is. I'm not sure Rochester is available, or the Silomar stuff. But it would be useful to have that list. And we've gotten quiet, so I can take that as an indication that we're about ready to pack it in. Anyone else care to make any other further pronouncements? Going once, going twice. All right. Without further ado, Brad, I think it's time to pull the plug on the recorder.